animals to see. Light is a form of energy that enables human beings and animals to see. Of course, we know that light is very important, especially during the process of photosynthesis, which is the process through which plants manufacture food. Okay.
Yes.
Got the definition?
Yes.
It's a form of energy that enables human beings to. Of course, light travels at very high speed. The actual value is 299,700. 299,792,458 meters per second. And generally, this is approximated to about 300 million meters per second. That's why you find the extent per 8 meters per second. Of course, in air, the speed is slightly slower. The speed we give of 299,792,000.
An electric bulb.
An electric bulb, yes. One's there.
A glowing worm.
Glowworm, or what you call a firefly. Joel?
Stars.
Stars, yes. Nick? Elvis?
A very red hot substance.
Red hot substance. So these are sources of like Jekai?
Are luminous sources the same as natural sources?
No.
Well,
No.
they may not necessarily be the same because you can have natural sources, but that are not luminous. We can have natural sources of light, but they're not luminous. Natural, basically, what is occurring naturally. Yeah?
Yes.
So they may not necessarily be luminous. We can have artificial sources, for example, light bulbs, which are luminous sources of light. Okay?
No.
So the other type of sources is non-luminous sources. So we have luminous sources, we have non-luminous. And non-luminous that do not produce their own light, but reflect light from other sources. For example, any object you look at and see will be a source of light. Any object. Because for you to see, the light must fall on the object first. Then the object reflects the light to your eyes. Or the object itself is producing light that gets to your eye. That's how we are able to see. Get this right. If an object is non-luminous, what happens is that there has to be light falling from a different source. Falling on it, then it reflects so that the light gets to your eye, and that way you're able to see. Otherwise, you would not see an object if it doesn't reflect light. So if light falls on an object, then it reflects, and you're able to see. It now becomes like it's a source of light, which is a secondary source, which is producing light from other sources. And this sources that do not produce their own light but reflect light from others are known as non-luminous sources. Okay. What are
Yes.
some examples of non-luminous sources that you may think of?
The moon.
The moon, which is a satellite of the sun, yeah? So the light falls from the sun to the moon, then reflects. Chris Mboro?
The moon.
Yes, the moon. Yes, reflects light from there. Nick Kimati?
Since we've said that non-luminous objects basically refers to anything that reflects light from luminous in order to be able to be seen, can we say that objects such as desks or lockers, since we can see them, can you say they are non-luminous?
Yes,
because we know they don't.
Yes, as long as they're not producing light, they are non-luminous.
Okay, thank you.
So examples: the moon, planets, plants, human beings, orchards, books, building, cars, etc. All these are non-luminous sources. Kimati?
No,
Nick?
I already asked my question and you answered.
It's only that your hand is still up.
Oh,
The icon of your hand is still up. Okay. So human beings, animals, and the like are non-luminous sources. Share a screen on that. So non-luminous sources is objects that cannot produce their own light. They reflect light from other sources. Animals and human beings are able to see them when light falling on them from luminous objects is reflected. You notice that when you use a torch and spotlight at night, if you shine the light on whatever you want to see. That's why I say light falls on the object first, then is reflected to the eye, and that's how we are able to perceive. Okay, it is not light from the eye to the object; it is from the object to the eyes. That's how we are able to see or perceive objects. And we said the examples of luminous, non-luminous sources, we have them there. Moon, planets, human beings. Now, yes.
What about a mirror?
A mirror.
Yes.
A mirror will also be a non-luminous source because it is reflecting light from a different source.
Okay.
Parallel, just as the term refers, parallel is beams that the ray, we have a group of rays, but the rays are parallel to each other. They are at the same distance from each other, and they form straight lines that are parallel to each other. That is a parallel beam. They are perfectly parallel to each other. Then they have a divergent beam. Divergent, that would mean that the light, the beam seems to be spreading out and becoming wider as it moves away from the source. That would be divergent that we have in the second diagram. Then we have convergent. Convergent beam, it means that the rays are coming and meeting and converging at a certain point. That's why they're convergent. they are meeting at the point. So we have three types of beams: parallel, divergent, and we have convergent. So the beams are either parallel, divergent, or convergent. Divergent will be spreading out, convergent will be converging or coming together at a point. They have types of objects. We have types of objects. Now, we fit window panes, and we have different types of panes. Yeah. We notice that there's some panes that you see through, the others that you don't see through. And of course, you can block light completely. So there are three types of objects when it comes to light. One is opaque. What do you know about opaque objects in light? What do you know about opaque objects in light?
They do not allow light to pass through them.
They do not allow light to pass through the code. They block light completely. Nick, your hand is raised.
Jerry already answered the question.
Okay. Then, of course, we have transparent objects. What is a transparent object? Transparent.
Objects are the ones which allow light to pass through them.
Allow light to pass through them.
Yes.
Yeah, but there's something missing in it.
And we can see
We can
clearly
see
through
clearly.
Yes, they allow light and they're able to see through them. Those are transparent. Then, of course, you have the third type of object, which is translucent. What is a translucent object? What property is there about it? They allow light,
light to pass through, but we
Yes.
cannot see through them.
but you cannot see through them. So those are the three types of that. We have opaque objects. This will allow light through them, will not allow light through them. We cannot see. Stone walls, metals, wood, human beings, all these are opaque objects. Translucent objects, these are allow light to pass through them, but we cannot see through them. Frost glass panes used in toilets and bathrooms. We have grease paper. If you take a piece of paper and grease it, you allow light, but you will not be able to see through it. Yeah. Then you have transparent objects, ordinary glass, car windscreens, and all that. This will, I don't know.
Yeah, I was asking, what about a tinted car window? A tinted.
Now, tints, you might see through the tint, but what happens is that the tint largely reduces the light getting in. So a tint would be something called in optics, something called a Polaroid, very similar to sunglasses. You see sunglasses?
Yes.
When you put on sunglasses, even when the light is very bright, there's very little light that gets to your eyes, then everything appears darker.
Yes.
So with the tints, usually what will happen is that, usually if you look very carefully, you can see through it, but still not very clear, yeah?
Yes.
And the reason why you not see inside the car is that the inside of the car, when you have, the inside doesn't have so much light. There's not so much light inside, therefore will not have, and of course it's allowing very little light in. So the tint may not necessarily be translucent. It can be, have some element of transparency, but allows very little light to pass
Yes.
through. Okay. Somebody else had their hand up. Who was that? David.
Yeah,
Jenga.
yeah. So what
Yeah,
about
your hand.
the
The
A two-way mirror, which is opaque from one
Yes.
side, but transparent
Yes.
from the other side.
No, those ones are special types of materials. From one side it is translucent, from the other side it will be transparent. It's just a special type of material because mainly this one will be used where somebody wants you to identify maybe somebody on that side that they don't want the person to see you. Okay? Those are special types of objects, which really will not be classified as either transparent or on one side it will be transparent, on the other side it will not be transparent. Okay?
Okay.
Right. So those are the types of objects: opaque, translucent, and transparent. Now, notice that we are unable to see round corners. We are unable to see round corners. So somebody standing somewhere at a corner, you'll not be able to see them. And basically, it's as a result of how light travels. If you have a setting like we have in the diagram, I don't know whether we are able to see that. Able to see that?
Yes.
Yes.
So we have three. So we have three cardboards that are mounted, and they have holes at the same level. And on the other end, we have a bulb. Then somebody looking through the holes will see the light. But if you move one of the cardboard so that the line, they're not, now the holes are not line, the light is cut off. The light is cut off. And this just indicates that light travels in a straight line. As long as you have a uniform medium, it's the same medium, maybe air, then light travels in a straight line. And this property of light traveling in a straight line is what is known as rectilinear propagation of light. Remember I said rectilinear means what is the meaning of rectilinear? So it began. What is the meaning of rectilinear?
Straight.
Consisting of straight lines, yeah? A straight line. So the term rectilinear propagation just means that light travels in a straight line. That's how.
Yes.
I have some questions here. How does a person see an object? Yatani, are you there?
Yes.
So how does a person see an object?
When reflected on
The sound is on and off, Yatani.
When light energy from the object enters the eye.
So you have light falling on an object, then reflected from the object to the eye. That is how a person sees an object, yeah?
Yes.
Yes.
Ibrahim? Ibrahim, are you there?
Yes, yes, I'm here.
But let somebody else give the examples, yeah?
Yes.
There are luminous and non-luminous. What's the difference?
Luminous has
Luminous objects?
Luminous objects are
Yongesa?
Yes.
Yeah, your hand was up.
No, I wanted to ask a question.
Yeah. Waiting.
It is from out of the topic.
Well, let's wait, hold it until maybe at the end. If it's out of the topic, let's put it at the end, yeah? Okay?
Okay.
Just put it, but make sure you ask us we get to the end. One there.
I have a question.
Yes.
We have these terrestrial bodies which are known as the meteors.
Yes.
When they the Earth's space, they burn.
Yes.
They burn while decreasing their sizes and so. So where can we
Yes.
classify them? Where can we
As long
classify
as-
them?
As long as they're producing light,
Yes.
as long as they're producing light of their own, they are luminous.
Yes.
Anything producing light of its own is luminous. The non-luminous ones are the ones that are reflecting light from others. Okay?
Yes.
Nick?
I wanted to answer the question on the examples of luminous and non-luminous.
Let's differentiate between them first.
Okay, luminous objects refers to ones that produce a light of their own, and the non-luminous objects, these are ones that they cannot produce light of their own but reflect from the luminous sources.
Yeah, good. Luminous sources are sources that produce light, their own light. Non-luminous sources are sources that do not produce their own light but reflect light from other sources. So what are examples
Yes.
of non-luminous sources, of luminous sources?
Examples of luminous sources are the sun, stars,
Sun, yes.
bulbs,
Stars,
bulbs, the gluons mentioned, or the five fireflies gluons,
yeah, yes.
bulbs, fluorescent tubes.
Yes, all these are
Objects.
luminous. Okay, Chris, examples of non-luminous objects. Charles.
Non-luminous objects are like the moon, the planets, plants, people,
Yes.
walls, books, clothes.
All right, those are sources that do not produce their own light. Okay. All right. The next question, light travels in a straight line. Describe a laboratory experiment to verify this fact. Manzia.
Yes, a laboratory experiment to verify this practice. You first pick, you take a cardboard. You need to have just like a nail, and then you need to have a source of light. You use the nail
Yes.
to make the holes in the cardboard in a way that they are straight, and then you place a source of light in the end, and then you align them in a straight line in such a way that the holes are well, and you observe from the other end, and if they are aligned well, you see the light. And if you change the position of one cardboard, light will not be seen. which alters the source of light.
That's right. That's good. There's some hands raised.
Yes, but I can answer the next question as well.
Yes.
Mm,
Go ahead.
the
Yeah.
next question.
Yes.
I read the next question.
Yes.
Okay. State 3 cases as evidence to demonstrate that light travels in a straight line. So the first case, we can say from the sun as a source of light, it travels in various directions but in a straight line.
Okay. But you know, from the sun, we are not really able to tell exactly whether it's a straight line.
What about a
I
torch?
can see that, but again, you see the name may be divergent.
Yes.
One of the things is like we've said, when you think of somebody standing at a corner, do you see that? That's
No.
one thing you can say, the ability to see around corners. Maybe we can hold that for some moment to look at formation of shadows and all that. Yeah. Question 4, we can hold it for some time. The two other people whose hands are raised, your hand is still up and you have just been speaking.
Yeah, I've lowered it.
So we say that when you see objects, the light falls on the object. Ephraim. Yes, your hand is up.
What about the pinhole camera?
Yeah,
Can also be
yes.
can also be used to demonstrate that light travels in a straight line.
Yeah, that's why I said let's hold it for some time now.
Yes.
Let's hold it so that actually that question is coming earlier than it should. Okay.
Yes. Yes.
Now, whenever you walk, maybe in the morning or when there is sun, somebody, what do you think a shade is? What do you think a shadow is? What do you think a shade is?
I think shade and shadow have the same principle in that that shade or shadow. Okay, a shade is the so I can say the shadow is the result of that shade and the light coming into contact.
No, what is the result of the other? Is it the shade that is the result of the shadow, or the shadow is the result of the shade? Now, when you have light falling on an opaque object, what happens? A shadow is formed, isn't it? Now, when you think of a tree, yeah, and usually maybe on a hot day, we want to sit under the shade of a tree, yeah? The shade is that area that is protected by the opaque object. So when you have the shadow form, the dark outline is the shadow. Okay, the shadow is the dark outline around an object when you have light being blocked, and the area that is protected by the opaque object is what is known as the shade. So basically, they are not independent. We cannot have a shade without a shadow. Okay.
Yes.
Yes.
So we're saying it is the area that is protected by an opaque object that is called the shade. The shadow is the dark outline of the dark area produced on the ground by that is called a shadow. So that's it. When an opaque object is placed in the path of light, then the light is cut off. The dark outline is what forms a shadow. That is a shadow. And the space protected by the object is called shade. Sawa.
Yes.
Yes.
Now, when you have a source of light, depending on the size of the light of the source compared to the object that is placed before it, then we can have a source being small. If a source of light is small compared to the object, such that that source is said to be an extended source. An extended source. The extended source is a large source of light. A point source is a small source of light. Are we getting that? Joel?
Yes.
Yes. Yes.
Yes, sir. I had a
Your hand is
question.
up. Yes.
Let's say the source of light is larger than the object, but
Yes.
it's at a further away distance, making it seem small. Will you
No,
call
we
it a
say
point
it's
source?
more depending on whether the light is totally blocked. Okay. If it is larger than the object, you see, if it's larger than the object, it's an extended source. But there's something else that's coming. We said a small source, a point source is a small source of light. Okay. Then we say an extended source is a large source of
Light.
Okay.
Yes.
But
Yes.
and a point source, get this right. A point source can be used as an extended source. I hope I'm not contradicting you. You're not getting contradicted. You're getting confused.
Explain.
You're saying that a point source can be used as an extended source. Now, you've used a torch. Yeah?
Yes. Yes.
With a torch, when you have an object very close to the torch, what happens? You can block the light very easily, isn't it? Even with your hand. But what happens as you move the torch away from your hand? The beam diverges.
Yes.
Isn't it? And as
Yes.
it diverges, the area it covers becomes larger. Okay?
Yes.
So when you have it diverging, then if you place an object at a further distance, the light will appear like it's coming from a large object. It will appear like it's coming from a large source. Okay?
Yes.
Yes.
So we can use a small source as excuse me. Sorry, we can have a point source, but can use it as an extended source when we increase the distance between the source and the object, as long as the source is producing a divergent beam. So a point source can be used as an extended source when the distance between the source and the object is increased. Have we got that?
Yes.
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 Okay. So when we have a point source and we have an object, if we were to place a screen beyond the object, what forms is a dark shadow. A dark shadow.
Shadow.
If that dark shadow is said to be a total shadow, and it is also given the name umbra, U-M-B-R-A, umbra. Screen have that. So when we have a uniformly and totally dark shadow, that is referred to as a total shadow, this is called an umbra. Umbra. Some of us will say umbra. Where? Umbra. Did somebody will say umbra? So when you have a source of light, which is a small source, we have an object and we have a screen, it forms a uniformly and totally dark shadow. And this total shadow is what you're referring to as
Umbra.
Umbra. Okay? Now,
Yes.
when we have, of course, we're saying the factors that affect the type of shadow, the size of the object, and the distance between the object and the source of light. Those two. Now, if the light is from an extended source, this is what happens. If you have an extended source, you have an object, we have a total shadow at the center, a dark shadow. Then we have an outline outside. It's bordered by a partial shadow. So it appears this the dark shadow, the total shadow, and we have a lighter outline around the top.
Yes.
Okay. So this partial shadow at the edge is called a penumbra. The partial shadow, it's penumbra. And you see what happens. We have, of course, we just have two pairs of rays. We have the ray that is directed through the part of the object, the upper part, which is totally cut off, and that forms the
Umbra
shadow here. Then we can have a ray from here passing this other side and this side. So there will be some light getting to this edge, but not enough to remove the shadow. That's why you have a partial shadow. And when this happens, we say when you use an extended source, then it forms a penumbra and forms total shadow. The total shadow at the center, but we have an outline of a partial shadow around the edge, which is called the penumbra. Sasawa.
Yes.
That is where we use an extended source. Okay. Any questions so far? Any questions so far? You know, silence sometimes is worrying.
So there's no question.
You know, silence is worrying because you're not very sure. So basically, what will happen as the light and the heat moves away from the source, what happens? The intensity decreases. The intensity decreases as you move away from the source. We might find that they are too far from the Earth, from the space. That's why the heat doesn't. By the time we get, the heat doesn't get to the space. Okay. It's about, of course, as we move away from the source, the intensity decreases. Okay. Now, has anybody ever witnessed
Yes.
an eclipse? Which one did you witness? Solar or lunar?
Passion.
Solar eclipse. So what is an eclipse?
An eclipse is the shadow formed when the rays from the sun fail to reach the surface of the moon or the earth.
An eclipse is the total or partial disappearance of the sun or moon when seen from the earth.
Yeah, that's true. It is a partial or total disappearance of the sun or the moon as observed from the earth. Of course, it either becomes dark because of the shadow. It's a the eclipse is not the shadow, it is the disappearance. But sometimes we find there is some contradiction books telling us that it is the shadow formed of the earth or the moon as a result of obscuring the sun from the earth or the moon. Anyway, it's a total or partial disappearance of the sun or the moon as observed from the earth.
Yeah.
Of course, there are two types of eclipses. We have the solar eclipse, which is the eclipse of the sun, and you have the lunar eclipse, or the eclipse of the moon. So there are an eclipse something about annular eclipse, but we look at that later as we look at it, which is really not as another type of eclipse. It's about the sun. But we look at that. Now, a solar eclipse that is the eclipse of the sun, and usually occurs during at new moon, and occurs when the moon, the sun, and the earth are fall in a straight line. When they're in a straight line, and you have the shadow of the moon being cast on the earth, then you have an eclipse of the sun. So you have the sun, the moon, and the earth being on the same straight line. And when this happens, the shadow of the moon is cast on the earth. When an eclipse occurs now the orbit of the moon, the distance between the moon and the earth is large. There's a possibility that the shadow or the umbra of the moon does not reach the earth, and something like this is observed by a person on earth. So we have the outside appearing bright, but the center part is dark. This largely required because the disk of the moon is not large enough to cover the whole sun. Okay?
Yeah.
The disk of the moon is not large enough to cover the whole sun. And this, now we say that whatever is occurring is an annular eclipse. Annular is taken from annulus, Latin, meaning ring. Meaning ring. So what would happen if that is done schematically? This is what would happen. We have the sun, we have the moon. The distance, you notice now, the umbra of the sun is does not reach the earth. Does not reach the earth. So we still have sun rays here, but the moon is observed, but with a coppery appearance. Sawa?
Yes.
It appears with a coppery appearance. So we have two types of eclipses. We have the eclipse of the sun. We have the eclipse of the moon. We have the eclipse of the sun. We have the eclipse of the moon. With the eclipse of the sun, some points will experience total eclipse, some will experience partial eclipse. Which ones experiences a partial eclipse? Which regions experience a total eclipse? Which regions experience a total eclipse?
The places may be near the equator.
Well, not necessarily near the equator, but the places where the umbra falls, the points where the total eclipse is experienced, where the umbra falls.
Excuse me.
Yes.
Excuse me, Malim, can we say that the umbra falls central into the central part because it does not extend? As I can see in the earth, it has been denoted X, Y, and Z. In the umbra, we see it's falling at Y. So it falls exactly at the middle, or?
It will not be exactly at the middle. It will be a region. It will be a region, yeah.
Yes.
You see where they put P. Okay, the diagram doesn't come out very clearly. We try to expand it, see whether you see it. Usually, if you check the ray, let's go back to the diagram. Remember the one that's forming the umbrella?
Yes.
Where we talk of the total shadow?
Yeah.
Yongesa.
Yeah. Maybe at around when the year is ending.
The annular eclipse is formed during the eclipse of the sun, when the umbra fails to reach the earth due to the increased distance between the moon and the earth due to the elliptical orbit.
That's right, because it occurs when the distance between the earth and the moon is large and the umbra of the moon fails to reach the earth. Of course, due to the distance being larger, and that's what we have here. This diagram. Sasa,
Yes.
any other question on eclipse? Any other question on eclipses? Any other question on eclipses?
So is it fair to say that mostly the lunar eclipse occur during the night?
Lunar eclipse, yes, will occur during the night.
Okay.
It is during the night. Solar eclipse will occur during the day. Okay?
Okay. Yes.
All right. Now we can go to the question. There's somebody was asking a question. Was it Jakai or Presley? Was asking a question that was out of the topic. Now we can give you a chance to ask that.
Nyongesa.
Yeah?
It's me. Aaron.
Nyongesa, yes.
I was asking if it is the thermals that cause the birds to move in a circular manner in there, or is it by their own?
Birds or bats?
Birds.
Move in a circular
Manner.
during which situation? During what time?
The day.
Yeah.
The day. If it is the thermals that cause them to move like that, or they move like that by themselves.
The thermals.
Yes, somebody, Elvis, are you saying? What are you saying?
It is the thermals because of the convection when the earth gets heated, when the air is rising, the birds will tend to move in the direction because of the convectional currents.
Yeah, there could be convection current, but there's also the aspect of conditioning in biology. This aspect of conditioning. Yeah, that's just one of the factors. Okay.
Yes.
So anybody else with a question?
Yeah.
Yes.
Why can't the sun's rays of light move parallel? They move convergent.
They convergent or divergent?
According to the diagrams of eclipse, they are moving convergent.
The diagram of
Eclipse.
no, that one. Just rays that we are drawing to show. They just drawing rays to show. We cannot draw all the rays there, definitely.
Yes.
So you just choose specific rays to indicate, to have a clear, to have just a glimpse of what is happening, to show what is happening. So basically, it's not about being convergent. They're just taking a ray of light that is moving from the sun to the edge of the. Let me share that so that we can look at it better.
Yeah.
Share it. Share. So what we're doing is we are looking at for a shadow of the moon to be formed. You're just imagining what is happening. We can have a ray from the sun from here, coming to the edge of the moon that will move straight to a point on the earth. Another one from this edge to the edge and straight to the earth. And of course, another one here. We're just using rays to show the so we're saying it's out of observation of previous occurrences and also looking at the observing the movement of the moon and all that. So,
Yes.
Yes.
So is there any other question?
We want to really look at in our next session.
Yeah.
Our next session.
The next session. We'll still continue and look at something else. But I'd like us to look at a question that we left out. Evidence of linear propagation of light.
Okay, thank you.
Aaron?
Yes.
What evidence we have for linear propagation of light?
What?
Linear propagation, that light travels in evidence we have.
Evidence.
Yeah.
We can use the paper and string.
That one was that the fact that you're able to see around corners is one. Formation of shadows.
Two.
Does it?
Yes.
Does it show propagation of light?
Yes.
So we have
the cardboard experiment.
with the boards showing that when we have the boards and have one with holes that are in line, then we move one of the cards, the light is cut off. That shows linear propagation of light. Okay.
Yes.
So please take care of yourselves. I don't know, we started at 38, then some people left, or maybe now we are 27. That is half of us, yeah?
Yes.
Okay. Take care. We'll meet next week. God willing.
Plus win plus B to end the game.